let's talk about our next part of conditional probability. And so we're going to do this general multiplication rule and discuss it through tree diagrams, okay? Another strategy, a technique to kind of understand this conditional probability. Okay, so we're first going to start with an activity. And what we're going to do is play a game, and I have a Desmos that you can go to get the simulation of this game. So first, we've got, in fact, let's actually show how you're going to go to that. We're going to go to our Canvas and go to the day's lecture video page. And I put the link to the simulation on that page. So that looks like, let's get to that. Let's see. Here it is. All right, so we've got this right here, Desmos simulation for the card game demonstration. So when we go to that, then it pulls this up. And I'm going to continue as myself. You can sign in as your Google account. So here are the rules of the game. There are 5 cards total that you are going to be drawing between. 2 of them are aces and 3 of them are kings. Okay? So 40% and 60%. The player clicks on the new hand button and it records the results in the table. And then they record the results in the table. You will be considered winning if you get a pair of aces or a pair of kings. Now, think of what's happening because this means you're pulling from the deck and you would have to get 2 aces or 2 kings. That means you take one and you keep it out. Okay, that's important. So this is conditional. So conditional, you want to get another ace conditional upon you getting the first ace. So we're going to simulate that event. So in the simulation, you hit next. And here we have new hand. I think that I've already played this, so it won't let me play that again because I've already done it 10 times. Darn. So I can't show you. But if I click this new hand, then it would scroll this, roll this, and you would then get a new set of cards. If they are both the same, then you would come over here and you would record ace, ace, and did you win or lose? But you don't need to go through all this typing. Just use this technological simulation and then come in here and write that down. Ace or a king, so ace, ace, win. King, ace, lose. Okay, so if you get a pair of aces or a pair of kings, so just do it right in here instead of technologically. And then do come down here at the bottom, however, and technologically, so that I can collect everybody's data, put in what based on your simulation results, what your probability of winning is. So that means you're going to take your 10 times and see what proportion of times you won. All right. So it might look something like this. First one, I got ace king, and that was not winning, and so on. So what happened was out of all 10 of these trials, 3 of them were winners. So I personally won 30% of the time. All right. And then we would collect the whole class data, and we'll do that a period at a time. But here's an example of whole class data. If we had 30 students in there, there would have been 300 trials, and 116 of them won. So that is this percentage rate. All right. So it'll be interesting to keep track of this throughout the day as students complete their data. So now we are going to make a tree diagram of this theoretically what the probability should happen. What probability should happen. See, these are our experimental results, okay? What actually happened compared to now we're going to see what is theoretically supposed to happen based on our conditional rules of this game. Okay, so here we go. If you pick an ace first, then well, to get an ace in the game, 2/5 of the time your first one is an ace. 3/5 of the time, oh, I guess the name of this is ace game. 3/5 of the time it's a king. Okay, so there's your rate of getting what you get on your first card. Then let's see what happens from there. Here's what then happens next. So we've got, if your first card is an ace, then your second card can be an ace or a king. Now, think about what happens. When you pick a card, if you picked an ace out, that means there's one out of the four remaining that are an ace, and three out of the four remaining that are kings. Okay? So here is this. So this is the second one being an ace, given that the first one was an ace. That's conditional probability. All right. So here we go. Now we're going to then calculate this probability of this. In order for this to occur, an ace first and then an ace second, here's what had to happen. 2/5 had to happen, and then 1/4 had to happen. So here we have 2/20. So 10% of the time you get, and I said 10% because that's 1 out of 10 would reduce to 1 out of 10. So 10% of the time you get an ace and then another ace. Okay? So the next one. 2/5 of the time you would get an ace, but then 3 out of those 4 times you would lose. Okay, so that would be multiplies out to be 6/20. So what is that? That's 3/10. So 30%. So that's a 30% time or amount that you would then lose. So we could also kind of keep track of that here. And I like to. So this one here, 10% of the time and we'll win. That's what's happening here. And then on this one, we've got, what did we say? It was a 30%, and we lose. Okay, so let's continue. So next, this 3/5 of the time, our first card will be a king. Well, then what could happen after that? You could get an ace or a king. So let's see. If you've taken out one of the kings, you now have 4 cards left, of which 2 are aces and 2 are kings. So 2/4 of the time it's an ace, 2/4 of the time it's a king. So let's do that together. 3/5 times 2/4 is, so this is another one of those 30% of the time. And what happens if you have a king and then an ace? Do you have a winner or a loser? And that is a lose situation. Okay. And then we have this next one here where we got a 3/5 of the getting a king and then 2/4 chance to get a king. So that's 3/5 times 2/4. That's 6/20. So we have yet again another 30% situation. Okay. But what we have is that results in a win because you had king, king. So see, here's our ways that we could win. We could do this ace, ace situation, or we could do the king, king situation. So I can see that theoretically, 40% of the time I should win. And 60% of the time, the other 2 parts, I should lose. So in theory, that's what should happen. And what did we get? Well, when we just did our 10, we got 30%. But look, as we got more trials, many, many trials, the cumulative probability, what is that? It will settle down to that true probability. And see, look, we got closer to that true theoretical probability of 40%. What is that called? The law of large numbers, you see. So there is our law of large numbers where our experimental, our actual is going to get closer to what it's theoretically supposed to do as you do more and more trials. All right, but we did that here with this conditional demonstration. All right, so let's see what else we have. So again, that theoretical we said was 40%. So let's take a look at this. What is the probability that the first card is king, given that the person won the game? Interesting. Okay. So this given that is this new idea that we're introducing, this conditional probability, conditional upon the first one being an ace. Well, in this case, what is it conditional upon in this question in part D? Conditional upon a person having won. So that looks like this. Conditional, right here, conditional upon, in fact, I think I'm going to scoot this page up so we can see that better. So let's take a look at that. Okay, so these guys are in the way. So conditional upon you having won. Okay, so then the way that will work is out of the 40% of times that you won, what proportion of those times was did you have a first card as a king and it was a winner? On top here, it has to be the intersection, both of these two things happening. Okay, so I'm going to stop just a moment because this is a very, very important thing I'm going to point out to you. A very common mistake that happens. So here we go. Because when people see this formula, they want to go, oh, 1 is 40% on the bottom, and then first kings goes on the top. Well, and if they do that, then look, 3/5 of the time, your first card is a king. That's 0.6. No, that's not what is supposed to go on top. What goes on top of the fraction is the intersection, the first king and the winning. The first king and the winning. That is not 60% of the time. That is first king and winning, and that was that 30% of the time. So that is why 30% is on top. So I took a moment to just really solidify that because that is the number one mistake that my students make. If you can take this point to hone this home, then hopefully we cannot make that common mistake. All right, let's move on. Here we go. So here's another example. Let's do this. I'm going to give you a moment. Go ahead and pause. See if you can't read this situation and then make yourself a tree diagram. By the way, I think the reflection today or tomorrow asks you, when is it that you want to use a tree diagram as a strategy or a technique for your conditional probability? All right. And you want to do that whenever you have a situation where, oh, well, if you're a Republican, then Republican state candidate, then there's this probability for this and this probability for that. But if you are a Democrat, then there's this probability for the continental US and this probability for the non-continental US or whatever. So if the probability is different for one item than the other, you have several different conditional probabilities, several different types of conditional probabilities, then that's when you need to break it down. And that's when you use a tree diagram, when there are several different conditional probabilities. All right, so let me let you take a moment, read through this, and do it. Let's see how your tree diagram comes out. Okay, so hopefully you took some time to do that. We were told here that 3/5 of the time, 30 out of the 50 states went Republican, of the 30 states that went Republican. And then of those 30 states, conditional upon you being one of those 30 Republican states, 29 of them were in the continental United States. So 29 of those 30 were continental U.S., and 1 out of those 30 was not continental U.S. Okay? And so then here's those probabilities. All right, next, conditional upon if you are one of the 20 states that went Democrat, that had the Democratic candidate, then here's your results. 19 of those 20 were from the continental United States, and 1 of those 20 were not. Okay, well, be aware that those are different probabilities. You know, this Republican 1/30th of it is smaller amount than the Democratic 1/20th of it. Okay, so that affected these probabilities over here. But when we multiplied it, then of course, 20 times 50 times 1/20th is how we got 1/50th. 20/50th times 19/20th is how we got 19/50th, and so on. All right, so you then multiply those two conditional probabilities together, and here is our total amounts over here. So 29 out of the 50 states were in the continental U.S. of a state that went Republican. Okay, so that's what that looks like. So let's answer some questions. Here we go. First question, what is the probability that a randomly selected state in the U.S. or is continental U.S. and went Republican? Okay, so let me go find that section. Continental U.S., well, that's these two, this section here, this little wing right here. Continental U.S. is this little section and this little section, but it says continental U.S. and Republican. So then that is just this top little strand. So that's 29 out of 50. All right. Next, we are then asked a conditional probability. We are saying, given that a randomly selected state is not in the continental U.S. So that is what the denominator is going to be. That's going to say, out of all of the non-continental United States ones. So here we go. Let's look at that. That's this and this. There's the non-continental United States. So out of that, so the denominator is the 1/50th plus the 1/50th. All right, so here's how that looks. So given that it's a non-continental state, then it says what's the probability that it went Republican? Okay, so on the bottom is the total non-continental ones, and the top is the Republican portion of that non-continental. So both of those, that strand, that was those two things, the Republican and non-continental, and that was one of those pieces, that top piece. This 1/50th out of the total 2/50ths. Okay, so from that, we develop that general multiplication formula, which hopefully you can kind of see what is happening. Look here. Here it is. Probability of A given B. All of the B probabilities on the bottom, but the top is the intersection of both A and B. The number one mistake students want to do is they want to just go probability of A over the probability of B. That's wrong. It's not just probability of A on top, it's the intersection of A and B. So let's fix that number one mistake so you don't fall for it. All right, let's do another question. Here we go. Let's see if you can write this out. Given that the randomly selected state is continental. Okay, so that's this. Your straight up and down line is the given that. Given that it's in the continental United States. So we need all of the continental United States ones. Let's go find out what that is. So all of the continental United States, again, was the Republican continental ones, the 29 out of 50, plus the Democrat continental U.S. ones. So we're going to add those two, 29 50ths plus 19 50ths. So the denominator should be that, let's see what that is. The 29 plus 19, so 48 over 50. Okay. And then the top part is, what is the Democrat continental U.S. portion? Not all 20, oopsie, not all 20 out of 50. Not this. That's just probability of A. That's all Democrats. No, it is the Democrat continental portion. That's the 19 out of 50, not the 20 out of 50 is the numerator. Okay? So then that takes us to this. So here we go. That brings us to that 19 out of 40, which was 0.39 something. Okay, try the next one. Given that the randomly selected state is not continental U.S., what's the probability that it went Democrat? Okay, so take a moment. Let's see how you do on that. First, I write it out mathematically. Given that, straight up and down line, non-continental. And if you remember correctly, that was those 1/50th plus the 1/50th. And you know what? The Democrat part was also 1/50th. So that comes out to be 1/2. All right. So that is the development of that general multiplication rule. So let's see what's happening next. Here it is. And so this works whether we have independent events or not, because see, it's taking into account this conditional upon you being a part B. So given that you are probability B, or you have this event B happening, okay, the total B probability is on the bottom, and the intersection is on top of the A and B. And here it is, the conditional probability rule. Here it is with those symbols. Event A given event B. All right, so now we're going to practice some more of those. But I think the next one has its cards in it. So if you needed to take a moment to study what all's in a deck of cards, here it is real quick. 52 cards, 4 different suits, 13 in each suit. So there are half red, half black. The face cards are the jacks, kings, queens. Okay, let's move on. Here we go. Let me let you look at these and see how you do. What's the probability that the card is a heart given that it is red? So see, I guess I didn't write that out like this. I mean, I could have done this. Probability that it's a heart given that it is red. Okay, so you can do that. So on the bottom is the 26 reds. And on the top is the red hearts. And there are 13 red hearts. All right, try the next one. The card, not the car, but the card is red, given that it is a heart. Okay, so that's interesting. Think about that. What's the probability that it is a red card, given that it's a heart? Well, guess what? There are 13 hearts and 13 red hearts. Okay, so that's 13 out of 13, which is 1. All right, let's see if we can't finish this out. So take a moment, try the others, and then we'll check them. Okay. All right. Here's how C and D came out. Card is an ace, given that it is red. So out of the 26 red, 2 of those red are red aces. This is not 4 on top. That's 4 aces in the whole deck, but we need the 2 red ones, the red aces. Okay, in the bottom, given that it's a face card, there are 12 face cards. We want the queen face cards, and all 4 of the queens are face cards. Okay, moving on. So now, here we go. So this one I found, let's see, let's see, what percent. So here we have the biology majors. We're going to take a course in biology research, and I think I'm just going to show you the answers on this one and let you talk it through because my battery on my computer is just about to die. So I think I had even come down here and made a Venn diagram of it to kind of talk through it. Okay. And so I put those in there. So they were all the biology majors. 52 had taken statistics, and then 23 had taken computer, and 7% had taken both. So I made a Venn diagram. Remember, according to yesterday's lesson, you could do a two-way table if you wanted. All right. But take a moment and study through what we have got here. Ineligible, they couldn't take it. Okay. So I'm just going to leave this here and let you take a look at it, and you can look at the notes and study that. And so I'm not going to have time to go through the explanation on that because I'm afraid my computer is about to die. But notice these are not disjoint because you can take, because 7% of students took both statistics and computer. All right. I think then what I'm going to have to do is I'm afraid that I'll just go ahead and finish this video out with a second one going over examples 5 and 6 so that I make sure that I have gotten that taken care of. And so because these will take a little bit of time. So go ahead right now and go through and read example 5 and see if you can make a tree diagram. What happened was when I started reading this, I was like, oh, if the first flight's on time, then there's these conditional probabilities. If the first flight is delayed, then there are these probabilities. So if you have several conditional probabilities, that's when your brain should say, ooh, I should probably organize this as a tree diagram. Several conditional probabilities. So take a moment to finish that example 4 if you did not, and then take a moment to do this tree diagram, and then I'll come back in a second video in the morning to go over that example with you and make sure you have got a strong hold on that.